Good morning. In this lecture series, we see about the simplest problem based on the simply supported beam. It is the under the method of Ritz method. So, what is the next thing we have to solving for the simply supported beam? Let's consider the beam is supported end with the two supporting beam. The load can be is either the different types is called as a is either is a point load or UDL distributed load. That is, a distributed load also can be very uniform variation load and uniform distributed load. And master the fundamental of the beam analysis through the practical examples and the clear explanations of the key concept in the structural engineering. So why is a simply supported beam? So the support the configurations and the momentum characteristics and the common applications. The support at the two ends, the one pin support and one roller support that allows the horizontal movement. The movement of the characteristics allow the rotation at the supports but prevents the vertical displacements creating the statistical determinant structure. And the common applications are the widely using in the bridge and the building floor and the various structural elements across the civil engineer project. The point load on the simply supported beam. As a point load, we have to apply the single and concentrated the location on the beam, the creating the distinct force and momentum patterns. So the key formulations are while the reaction force is Ra and Rb is a reactor at the two ends of the beam is considered is either A point and B point. So that is called as a Ra and Rb. So the maximum bending moments are the shearing force or changing the point loaded. So for example, is an example of the 10 kilonewton at the midpoint of the 6 meter from the beam. And what is a uniform distributed load is simply called as a UDL load. The load that will be acted as a entire beam at a uniform. So that is called as we have to represent as a kilonewton per meter. So UDL is a separated load evenly is across in the entire beam of the length. The represent by the intensity Q is a load is a Newton of kilonewton per meter is the load pattern is common on the floor, roof, and roadway surface. And they calculate the reactions and determine the maximum momentum and analyze the shear force. So while calculate the shear force, okay, is a variational formation of the support to mid span crossing the zero at the center. So visualizing the shear force and the bending moment diagram. So diagrams are essential tool that is reveals the internal force that helps to engineer predictive beam behavior under the various type of load conditions. So one is the point load, another one is the uniform distributed load characteristics. So one is the shear force jump the appropriate at the load location and the bending moment peak the directly under the point load. Linear momentum variation may be support and load. The shear force is varies linearly along with the beam and the bending moment for the smooth and parabolical curve. The summary and the practical tips are the master basics. The simply supported beam are the fundamental structural elements that they form the foundation of the structural analysis and design. The applying the standard formulating using the establishing the equation for the reactions and the shearing force and bending moments to analyzing the beam behavior accurately. Verify the unit carefully. Always check the unit of load in kilonewton and length in meter, the momentum in kilonewton meter. Consistent the unit preventing calculation error. So build through the practice, the work through the reverse the example to develop in the institutions of the accuracy combined point and distributed load for the complex scenarios. So what is the let's summary of the overall topic of the simply supported beam of mechanisms? We have classified into further is the analytical objective and a theoretical framework and applications. While the analytical objective is classified as a reaction, shear force, bending moment, slope, and deflections. When the theoretical framework, the basic beam theory, boundary conditions, and loading conditions. The applications are the structural response, structural analysis, and fundamental element methods. Thank you.